Welcome to this tutorial on Grafana dashboards for visualizing Kubernetes metrics. Grafana is a powerful open-source platform that helps us create beautiful, interactive dashboards to monitor our Kubernetes clusters. Throughout this video, we'll explore how to build effective dashboards that give us real-time insights into our container infrastructure. Grafana is an open-source visualization platform designed specifically for creating interactive dashboards. It supports multiple data sources, including Prometheus, InfluxDB, and many others, making it incredibly versatile. One of its key strengths is real-time monitoring with built-in alerting capabilities. For Kubernetes environments, Grafana provides native support for container metrics, allowing us to monitor everything from CPU usage to network traffic seamlessly. Creating a dashboard in Grafana follows a straightforward four-step workflow. First, we create a new dashboard either from the Grafana user interface or by importing existing templates from the community. Second, we add visualization panels, choosing from various chart types like graphs, gauges, or tables. Third, we configure our data sources by connecting to Prometheus or other metric providers. Finally, we write queries using PromQL to fetch the specific Kubernetes metrics we want to display. This systematic approach ensures our dashboards are well-organized and effective. When building Kubernetes dashboards, we typically focus on 3 levels of metrics. At the cluster level, we monitor node CPU and memory usage, along with overall resource capacity and allocation. At the pod level, we track individual pod CPU and memory consumption, as well as restart counts and status information. At the application level, we focus on request rates, latency, error rates, and HTTP response codes. These metrics together provide a comprehensive view of our cluster's health and performance. Let's look at a practical PromQL query example. This query calculates CPU usage by pod in the production namespace. We use the rate function to calculate the per-second rate of CPU usage over a 5-minute window. The sum function aggregates this data, and we group it by pod to see individual pod consumption. This query structure is typical for Kubernetes monitoring and can be adapted for various metrics like memory, network, or disk usage. Grafana offers several panel types, each suited for different visualization needs. Graph panels display time series data as line charts, perfect for showing trends over time. Stat panels show a single value with an optional sparkline for quick insights. Gauge panels provide visual threshold indicators, making it easy to spot when metrics exceed limits. Heatmap panels display distribution patterns over time. Table panels present structured data in rows and columns. Bar charts are ideal for comparing metrics across different resources. Choosing the right panel type makes your dashboards more intuitive and actionable. Grafana dashboards come with powerful features that enhance their functionality. Variables allow us to create dynamic filters for namespaces, pods, and nodes, making dashboards flexible and reusable. Annotations let us mark important events like deployments or incidents directly on our graphs, providing context for metric changes. Links enable seamless navigation between related dashboards, creating a cohesive monitoring experience. Thresholds let us set color-coded alerts that automatically highlight when metrics cross predefined boundaries, making issues immediately visible. To build effective Grafana dashboards, follow these best practices. Organize your panels by logical grouping, such as cluster-level metrics, namespace-level metrics, and pod-level metrics. Use efficient queries to reduce load on your Prometheus server and ensure fast dashboard rendering. Apply consistent naming conventions and color schemes across all dashboards to maintain a professional appearance. Leverage pre-built templates from the Grafana community to save time and learn from experienced users. Finally, version control your dashboards using JSON exports, allowing you to track changes and roll back if needed. Following these practices will help you create dashboards that are both powerful and maintainable.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.